Bryce waved at the silly man on the TV. Nice job, Bryce. This is October 5th. 26 days till everyone's favorite holiday. Can you call it a holiday? Is Halloween a holiday? Really? Why don't you like Halloween?
I like Christmas. Christmas is the best holiday. Christmas is the best holiday. Yeah, Halloween is the people.
I have to pause the recording before I say this. So, anyways, yeah. So for the next couple days, at least, probably a few days, we're going to be solving inequalities, and these are actually called linear inequalities. I need to specify that. So, you'll enjoy this, not in the sense that, yay, it's fun, but you'll enjoy it in that it's not going to feel like, I know fraction equations were really, really hard for some of you. This is never, I don't think, going to feel like that now. What we've done is we've laid the groundwork for all of this so that all 10 examples I do today and all 30 problems in your assignment, like today and tomorrow, you're going to find them, I hope, to be pretty mellow, or like they're not going to bother you because you have all the skills, almost all the skills. So there's a couple things that change when we move from equations into inequalities. Obviously, equations are what you've been doing for the last, I don't know, like 4 weeks or something, right? It's like all we've been doing. So what happens now for the next week or so is we don't see any equal signs, we see inequality signs. And you guys will remember that the inequality signs are this one. What does that say? Is greater than. Very good. And then another one is this blue one, and that says is less than. And you'll remember that the other two aren't really uniquely new inequality signs. They're just modifications of these. So like if I took and put one of these straight lines underneath that, greater than or equal to, right? So that changes things, because now it says that, like, if I said x is greater than 4, then x has to be a number that's literally bigger than 4. But if I change it to or equal to, then I say, oh, x could also be 4. And so putting that little line underneath it makes it a new sign, but really it's, I don't want to say it's the same, but whatever. And then the same for the less than. So your 4 inequality signs are greater than, less than, greater than, equal to, less than, or equal to. And that's what you're going to see now for the next week. You won't see any equal signs, just those. And so how we solve them, you'll see here in our 10 examples. I have no idea how long this would take, but we're going to see things like this. So, like I said, welcome to the next week. This is all we do now. Our missions are to solve first, and then something new that we don't do with equations is we're going to graph. Have you guys ever done these? I always ask this because you come to me from different backgrounds and different classes. Have you done these where when you're done, you go on the number line and you put like circles and draw arrows and shades?
Yeah, last year.
Nice. So that'll help.
No, it was at 6th grade was all, we were just being
The key here, and if you want to play silly games about like you know, the less than sign is like an L that fell over and the greater than is like a alligator, and if that's, I really don't have the time or patience for any of that. I feel like, you know, if you can look at that thing on the wall, that round thing that has the numbers on it, what's that called? Oh yeah. Yeah. See, at some point in your life, you just memorize that word, you look at that and say clock. I think if I put one of these up, you should look at it and say is greater than. I mean, I don't understand why that would ever be a thing. So if you have little cute games and things that you use to memorize which is which, then you can go ahead and get down with your bad self. I personally would prefer that you just memorize the 2 signs. I don't think it's asking that much. So having said that, this says 4x plus 11 is less than negative 13. Now, how we attack it, good news, is just like we would attack an equation. So go back in time a few weeks, and what would we do to both sides? Subtract 11. Good. So my next line is going to say 4x is less than, and what's negative 13 minus 11? Very good. Negative 24. And you'll see me, I said this, I started doing this a week or 2 ago. I'm not going to keep showing as much work as I did in early September. You know what I did. I did minus 11 and I did minus 11. And that, I expected that of you 5 weeks ago. If you don't want to show that, you don't have to. Just don't mess it up. And then the last step is to do what? We divide by 4. And I'm going to say then that x is less than what? Good. So here's the deal now. This is kind of where things change today. Our solution does not state that x has to equal -6. When you solve an equation, you're finding a very specific number that makes an equation work. When you solve an inequality, you're finding an infinitely large set of numbers that makes an inequality work. It's like, so like x could be anything less than -6. Anything. And so what we're going to expect of you, not on every problem, but I'd say probably half of your homework problems, some require graphs, some don't. But when you'll be in Delta and you'll know you're supposed to graph because you'll see it, like it's obvious. So if I wanted you to graph this, this is the way I do it. I'm going to go on a number line. And if I'm making my own number line, all I'm going to do is mark the number that I care about. I call it the boundary point. And the boundary is -6. -6 is where the rubber meets the road, so to speak. So what I want to do is establish and say to the world that -6 is not a solution. Like -6 is not less than himself, right? So the way we represent that when we make a graph is we circle, but we do not color it in. That's important if you're taking notes, that you make a circle, do not color it in. This becomes a math thing where math people understand the difference between a colored in circle and a not colored in circle. So the not colored in means I don't count. And then where are the numbers that are less than -6? To the left? So all I simply do is I shade my number line like this, and then I put sort of an emphatic arrowhead to indicate that the graph goes on forever in that direction. Kind of neat, huh? So that's just our visual way of saying anything in that arrow is a solution. Like I could pick -10. And that means if I go put -10 back up in the original problem, like look at where my blue arrow is at. And I just picked -10 because I wanted to, whatever. But if you put -10 in place of x, what's 4 times -10? And what's -40 plus 11? And look at that, -29 is in fact less than -13. You would find that result with any number you pick that's less than -6. So that's what we're doing today and tomorrow and the next day probably, is we're finding not numbers that work, but infinitely large sets of numbers that work. They're called solution sets. All right, so next one. I have -4 plus 5x is greater than or equal to 16. The first few I give you, we're not going to encounter any fractional sorts of answers, but that's going to change, I think, on example 4. And after 4, I won't pay any more mind to fractions. I just wanted to give us a few warm-ups with nice, pretty numbers. So what would we do first on this one? +4, good. So my next line would say 5x is at least, that's another way to say greater than or equal to, is at least. So 5x is at least what? Now, this is where we really run into a danger zone. It's hard sometimes for people to make the jump to not showing work. I have to add 4, so you're not allowed to say 12. The human brain sees a 16 and a -4 and wants to say 12. If you're at that point where that was still what you thought, you need to keep showing your work. Once you're ready, make the leap and say, I know I'm adding 4. I know it's not 12. I know it's 20. And then what do we divide by? And that gives us x is at least, what's 20 divided by 5? 4. Very good. So again, the expectation, if it's a graphing problem, is I'll make a number line, unless there's already one provided for me. And I'm going to make a mark at 4. 4 is the interesting spot, the boundary spot. Very good, Bryce. So this time we color in the circle. The colored in circle is our indication that that point counts. That's my way of saying, yeah, I'm a boundary, but I do count. I'm in the club because I am greater than or equal to myself. And then where are the numbers that are greater than 4? So we simply shade this direction and put a big emphatic arrowhead. Good. All right. So the problems now are going to start to get harder as we go. So now that you kind of know the basics, we're just basically solving equations, even though they're not equations. So next example is going to be a really big determining factor in how the next week and how the next quiz goes for you. So watch out. You know the algebra. You just know. What do we do first? Minus 3. So remember, you heard yourself say that. So don't you go saying 24 here in a second, right? Minus 3. Show it, don't show it, but know what you're doing. The next line will say negative 2x is greater than. Good job. Now, this is where I really need you to do something in your notes that somehow, and some people use colors, some people go home and highlight their notes like on their own time. What's about to happen is really, I say, this is going to determine how well you do now for the next while. Then you ask your Algebra 2 friends, they'll tell you this is a big deal. So what do we have to do now? We do. And I'm going to get a final answer, and this is not a mistake, that looks like this. It would be easy for you to look up there and say, oh, Mr. Ahern, you need more coffee, dude. I did that on purpose. So obviously I got X by itself, and obviously 18 became negative 9. You don't have any questions about that. What's going on with that sign in the middle? Why? Because I divided by a negative. And that does not happen if you divide by 2. I don't care what the 18 is. The 18, the recipient of the division can be positive, negative. That's of no importance to me. But that's something that you got to get in your notes and in your head and stuck, and don't let it go. That when you divide an inequality by a negative, the Pac-Man in the middle, whoop, 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 flips around 100% of the time. So let's make a quick sketch of a graph. I don't know if we'll graph them all in our notes today, but it's a good thing to practice. And so my boundary is going to be set at negative 9. What kind of circle? Right, open. We'll call that an open. So we call them open and closed. So an open circle. And which way do we shade? When you're in Delta Math here in a little while, once you get started today, to change your circle. So like when you want to make a graph, you click on your boundary and drag, and it'll make your arrow. If you want to change the circle from open to closed, you just click the circle and it switches it back and forth and back and forth. Okay. Doing these in Delta Math is really nice. Super easy, like user-friendly. All right, let's go again. This will be the first one that I think might cause a little stress. I expect maybe there'll be some questions here in about a minute and a half when we're done with this. It's not the algebra, it's the sort of idea at the end that's going to get us. So, the algebra. What do we do first? At 11, which we drop the negative 7x, we drop the sign, and then again, the basic math has to be good. What's negative 20 plus 11? It's negative 9. And now what do we have to do? Divide both sides by negative 7. And so here it goes. It will. So I'm going to drop my x down. I'm going to switch my inequality sign because of what I did. I divided by negative 7. And then what's negative 9 divided by negative 7? Good job, you guys. There's going to be some decimal garbage. Good job. That makes me proud. 9 sevenths. Now, here's where I have some issues. And you're a wonderful group of learners this year. So don't worry about the fact that it's a fraction. 9 sevenths is just 9 sevenths. So I'm just going to, boom, mark it. You want it to be 9 sevenths? So it shall be done. You name it whatever you want. You don't have, some people would put like a 1 and a 2 and make little tick marks. You don't have to do that. Which way will we shade?
To the right.
But and listen, there's a way to fix this. This is a conversation that we'll have again. I'd like to have it fewer times than more, but if you listen carefully now, and I hope you trust me by now. It's October. You should trust me. This inequality, while it's correct, it sucks. And why I say that as a teacher is because we have discussions where we're like, well, I think I should shade to the right, but it says less than. Should I shade to the left? You can always solve this problem. Ready? Listening? Ready? Always write your inequalities so that the variable moves to the left. It will make it make more sense to you, I promise. So I look at this and I think, I don't like the relation the way it's written. I always wanted to say X is blah, blah, blah. X is blah, blah, blah. I want X is blah, blah, blah. I don't want blah, blah, blah is X. That freaks me out. So what I'm going to do is I'm going to flip it. This is what I call a cosmetic switch. It's not mathematical. I'm not switching anything for a mathy reason. I'm just saying, so if 9/7 is less than X, oh, then X must be greater than or equal to 9/7. Cosmetic meaning for appearance only. It's just to make us now not have to have a discussion, because now if I ask you, so here I'm going to make my circle, I'm going to make it closed. And now when I ask you which way should we shade, there isn't going to be any discussion around the room. Everyone's going to look and go, oh, to the right. That's easy because it clearly says X is greater than. So that's my advice to you, is to always make sure at the end, if your variable winds up on the wrong side, so to speak, take 5 seconds and flip it. It'll help you. All right, you ready to move on? You got the basics, eh? Okay, next one. 4x minus 12 is less than 7x plus 9. Just like with equations, we made the transition to, oh, now we spent a day learning, oh, there's variables on both sides. We don't need a whole day because, again, we got the basics. You know how to solve equations. So you're going to now today put yourself into one of two groups. Whether you know it or not, today you're going to make a choice. And before you leave here, you're going to decide. You just will. Are you a I always want the variable on the left kind of person? Or are you a I always want my variable to have a positive number in front of it person? And that's a decision I learned a long time ago I can't make. I can't tell you that. I can give you the reasoning behind both. If I do this, if I subtract 7x from both sides like this, what is the downside to what I did? I made a negative. And why now does that matter to me? Because I'm going to have to flip it, right? You're going to have to decide at some point which to you is the lesser of two evils. You've heard that expression before. You're either going to have your variable on the side that we don't like, but it'll be positive, or you can have your variable on the side where we want it, but it's going to have a negative. You can't work at that out. Like that's going to just happen. So if I just want my variable on the left person, then I would do what I did in blue. If I today decide that no, I don't like that stupid flipping the sign thing, I'm going to forget that, then I'm going to be this person. And I'm going to say, I don't mind that I'm moving my x's to the right, but this way here, if I subtract 4x, like I've talked about before, take the smaller x, then if I do it this way, now I'm guaranteed, you see, to have a positive number in front of my x. That will always be your choice in problems like this. You've probably already made up your mind as to who you are. Some of you right now think, I like it like this because I don't got to do this stupid divide by negative, and I don't know. You'll decide. So let's proceed. What's the next step? Minus, subtract, whatever you want to call it. Take away 9 from both sides and you get negative 21. And now what are we going to divide by? So I am not going to switch the sign mathematically because I divided by a positive 3. However, so that I don't get this wrong, I am going to switch the problem around now because I like my variable to say things that make sense. So I'm going to do a cosmetic flip now, and I'm going to just say, oh, so x is greater than negative 7. And if you're one of the people that did what I did in blue and you subtracted 7x, you got to the same place. It looked a little different, your pathway. Good. Right. There are going to be fractions with these eventually too. So we're getting into the later stages now. Got one more little easy one. And I honestly am mildly curious. How many of you would just think get to variables on the left? Don't care. That's fine. That's going to become your thing. How many of you would be like, I'm getting the variable to be positive? I get that some of you didn't vote, but that's again going to be your choice. What's fun about this problem? Try better. When I just asked that question and I said, who thinks they're gonna be just put the variable in the left kind of person, Mari raised her hand. And then I said, who thinks they're gonna be a get your variable positive kind of person? I saw Tegan raise her hand. What's good about this problem, Brycey?
The positive is on the left side.
It's gonna happen anyways. So whether you're Mari or Tegan or whichever group you're in, if you're a get the variable on the left person, you're going to add 3x to both sides. If you're a get the variable positive person, you're going to add 3x to both sides. I cannot think of any logical reason why someone would go, I'm going to subtract 2x from both sides. That's just weird. So regardless of which group we're in, we all agree we're going to add the 3x to the left side, giving us 5x. If I see you subtracting 2x on a problem like this, I'm going to probably send you in for some counseling or something like that. All right, just fair notice. Now, what do we do?
Subtract 4.
Subtract 4, giving us 5x is greater than -12. And then what do we do? Divide by 5, giving us x. Should I switch the sign?
No.
Nah. I don't care if the 12 is negative. I'm not dividing by a negative, so I keep it x is greater than what? Good. And you guys get the idea. I don't need to graph this one. You'd make an open circle, mark your boundary, shade it to the right. Piece of cake. All right. Time for the next level. You got a question, Kyla?
Yeah, so
Sure.
I'm kind of confused on how would it be?
You just place it wherever you want. So like if sure. So if you can promise me this, I hate to even say this. I'm gonna even though I'm recording myself, I'm gonna say I never said this. I'll just edit this part out. If you promise me to always get your x on the left, if you do solemnly swear, then the look of the inequality sign will give you a hint as to which direction to shade. Do you see how it looks like the tip of an arrow?
It's put out the way.
If your x is on the wrong side, if your x is always over here, if your x is on the other side, then I disavow any knowledge of what I just said. That stupid little trick I just showed you with it looking like an arrow will only work if you solemnly swear to always put your x first. But see how it says x is greater than? So I just make a mark on my number line at -12/5. I put a circle, I leave it open, and then since it says is greater than numbers are always to the right. So I'm just going to shade this way. Yep. And see how, like if it said x is less than 2, you see how that looks like a cool little arrowhead? But if you ever are and I don't know why people do this. Some people are just stubborn. If you're this person who's like, I'm just going to leave it like that, then everything I said was a lie. If you promise to put the x first, it'll always look like a little arrow tip. You should always cosmetically switch it. What I'm saying is some people actually leave their answers like this. You know what I call those people? Weird. Wacko. Bottom line, if you know what you're doing and you're going to be fine. Does that make any sense, Kyla? Nice. All right, next level. Here we go. So we learned how to solve equations over the course of like 2 weeks. We're doing all of that basically in one day today because you already know all the basics. You know how to distribute, you know how to simplify before you solve, you know all this stuff. That's why we can just knock it out in a day. All right, what do we do? Distribute is the perfect answer, the only answer. So I'm going to say 6, and then what? Minus 40x. Then what? And then I'm going to copy down my is greater than or equal to sign. And then I'm going to copy down my 3x because, well, he doesn't get to play. And then what? And then what? Good job. So those basics are in place. That's what September is for, is getting that in line. Now we're ready to roll for the year. We got it. Now we're going to combine like terms on the left, and we have 6 plus 45, which is 51. And then on the right side, we have 3x minus 7x, which is -4x. And then from here, You are now in two different groups. If you're like Mari and you like come hell or high water, I'm putting the variable on the left, Mari's going to add 4x to both sides. If you're like Tegan, you're going to add 40x to both sides. Don't care. Zane, what would you do? So you're going to add 40x to both sides. So Zane says, I like my variable positive. Don't care if it winds up on the quote unquote wrong side. It's all good. So if we're doing it the Zane way or the Tegan way, or anyone else, if this is your thing, then your problem is now going to say 51 is greater than or equal to 36x plus 7. And then what do? Minus 7, leaving us with 36x still on the wrong side, but it's all good. 51 minus 7 is 44. And then we divide both sides by. What's that? I'm sorry, I'll slow down. When you say Jesus, that makes me think, gosh, I better slow down. Jesus is coming to the rescue here. Make Mr. Ahern slow. You good? Okay. Now what do? Divide by 36, which is going to result in x all by itself. The sign will not change. And 44 over 36, if we divide them both by 4, is 11/9. Got to reduce those fractions. So what do we think of this answer? Yeah, it's poopy because the x is on the, quote, wrong side. And there are some math purists who would say, what are you teaching these kids? That's not wrong. And I'm like, man, I was looking out for the kids. Let's fix it. Let's do the cosmetic swap. So we're going to say x is actually what? Less than or equal to. If you switch it, you got to switch the everything. The Pac-Man that looks at things follows the things as they move. It is. Okay, so again, to graph this, once I promise to get my x on the correct side, it's going to just match intuitively with what we think. We're going to make a mark at 11/9. We're going to put a circle, open or closed? Closed, and which way will we shade? To the left. Good, good. All right, you ready for fractions? Yay! There's a reason we do fraction equations before we move on, because now I can put fractions wherever I want, and most of you can just flex and say, I got this. So I got to do a couple of these, and then we're done. We are not scared of the fractions. We would have been a week and a half ago, but not anymore. We do not care. We are not afraid. We are not scared. What do we do? Okay. We can. I'll try it. Maybe this will be pleasing for some of you who do it this way. I personally would just distribute the 1/4, but whatever. I'll do whatever. So let's do it. It's not a bad move in this case since all the fractions are out in the open, so whatever. So if we multiply by 4, we have to remember that the 4 hits everybody that's in the open. The only place the 4 will skip is the things protected in the little safe house. So we get 4x plus. I love the fact that we've gotten to the point where more light bulbs are coming on. I'm not hearing 12s and 2s and things. I'm just 6. Boom, done. 4 times 3 is 12, divided by 2 is 6. Beautiful stuff. Is greater than.
-6x minus.
And I'm going to ask you this, even though we've already taken the quiz. I know you're about to flex on me and tell me the what for. Why didn't I put parentheses and put a 1 here? Because it wouldn't matter. What's the point, right? Good job. So when it's a 1, we're like, I'll skip that nonsense. I don't need that. And then minus what? Fractions are gone. Proceed as normal. Left side is 4x plus 6. The right side is -6x minus 5. And again, this goes back to, I keep picking on Mari and Tegan. I hope you guys don't mind, but Mari's my get the variable on the left person. Tegan's my heck with that, get the variable positive person. They're one and the same in this example. If you want your variables on the left, you're going to add 6x. You want to get it positive, you're going to add 6x. So woohoo, we come together. So we get 10x plus 6 is greater than -5. You subtract 6, which would be what, Bryce? I'm sorry, what? Oh, negative. I couldn't hear you say negative. I must have some blockage in my ear canal. Negative 11. And then what do we divide by? And should we switch the sign? Nah, we didn't divide by a negative. So x is greater than negative 11 over 10. Phew, done. It's empowering to be able to say now that I'm not scared of equations. I'm not scared of fractions. I'm not scared of parentheses. I'm not scared of big, long equations. We just don't care because our basics are good. We know when to distribute. We know how to kill fractions. There's something to be said. That's what September and Algebra 1 is for, is laying that groundwork. And I'm proud of you guys. So one more. Last one for notes, and then we're not going to have much time, but you might have time to like dive into Delta and do like 2 problems. But remember, tomorrow's just work, 55 minutes, just work. So what do we do? Yeah, if you tried to tell me to go fraction killing right now, I would tell you to go take a hike because it didn't happen. And those fractions are like, we're safe in the safe house. So it's not going to happen. So I'm gonna be copying some stuff down. I'm going to copy down the 3. The inequality sign, the negative 6x, and here we go. It's game time. What is 9 times 3/4? We don't like it, but we accept it. It's 27 over 4. Beautiful. Nothing to like about that. What's the next one? 9 times, here, I'll put the minus so we don't have to talk about the negative. I'll just say this. What's 9 times 5/3? I'm waiting for someone to say what it is. Thank you. I've been waiting to hear 15. So listen, sometimes, and it's okay, we keep hitting this and we keep practicing. When the math gods throw you a bone, you gotta take it. And what I saw in this problem was that my multiplier 9 divides beautifully by the bottom of the fraction. Don't overlook the hook. What is 9 divided by 3? 3 times 5? Jackpot. I'm not upset if you thought 45 over 3, but you're just making your life harder because it's going to come out quicker if you just zoom, hook it, divide, multiply, divide, multiply. And now it's time to probably get rid of some fractions. So let's put on some brackets. What are we going to multiply by? What are we going to get? $27x minus 60. And I know, again, having spent several hours intimately looking at these papers, a lot of points lost for people forgetting to finish the job. You got to go there, 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 and there. A lot of points lost for that. Everybody in the equation gets treated the same. You scale something up by 4, you scale everything up by 4. And then we're home free. We get 12 is no more than, what's negative 24x plus 27x? 3x. This was an instance in which the whole idea of, do I want my variable positive or on the left, it just never came up. It wasn't, the choice wasn't given to me. It's just, you get what you get. You don't throw a fit. So now what do we do? 72. And then what do we do? And 72 divided by 3. Anyone know that one? 24. And what do we think of that answer? It's mathematically really good. But I'm telling you, you should switch it. I know every kid who doesn't do it, they're like, I'm going to show this guy. Listen, thousands of kids before you have tried the same thing. Just take it from a guy who spent a lot of time with this. You're going to feel better if you switch it. You're just going to like it better if you switch it. So it actually says x is greater than or equal to 24. I like that because that's going to match my graph. So that concludes, as advertised, a very long batch of notes. But that batch of notes will get us through at least a couple more days of class. So you guys good? All right, why don't you flip open those Chrome books and see if we can knock out like 2 problems. That's our goal. 2 problems, dudes.